Original Appearance Manufacturing was founded in Ames, Iowa, and our flagship product is Quick Covers, a brand of slip-on rocker panels that make rusty trucks look as good as the day they drove off the lot. This is the story of how we went from an idea to a prototype to a full-fledged business. We'll give you a peek behind the scenes and share the ups and downs of starting a manufacturing business from scratch right here in the US. We are OAM and you're watching Made in the States.
My name's Luke. I'm an engineer here at OAM. I'm kind of a pretengineer, and I do a lot of the automation and electromechanical around the plant. Pretty much whatever breaks or blows up or a manual process that we want to automate. I guess I've taken that over now. I think I was on my honeymoon when the thermoformer was brought in. I wasn't here. I heard it was like straight debacleville. You know, like they had to put all these things under it and scoot it around, this, that, and the other thing. Zach probably did a few table flip moments because he had to buy some jacks. But, you know, I really don't know. But if I picked a week to be gone, that was probably a good one. And essentially when we got it, it was a hunk of junk. I mean, it's not very friendly, but it was not very usable. So about a year ago now, almost to the day, we started automating everything and, you know, just making it so anyone could run the machine. So this is one of our molds that we basically make our parts with. Now this is like kind of a remnant of the primordial soup of where we started out, where everything was super manual. That was our old original machine that we just have as a backup now. So the purpose of the thermoformer is, I guess that's how we make all of our parts. You know, without that machine, the methodology and how we actually produce things out of this plant, you know, that's what it's all centered around. We're always tight. We're always pretty tight for space. As you can see, we call it the OAM Tetris. So when we got it, and our old one, you know, they were about one part every 8 to 10 minutes. It wasn't very good. Now we got it with basically the whole process being automated. It's down to 3 to 4 minutes. So luckily we have some folks that are really good with body work to make this all work out. But like I said, you know, they get beat to death in machines like this, so they take a lot of maintenance and care. Obviously when we're doing this, all the pneumatics are completely de-energized before we climb in here. These cylinders below this mold, I can't remember what it was. It's like 3,000 or 4,000 pounds of force. So what we do with some of these molds is like what we would call plastic physics anarchy.
What is plastic physics anarchy?
I think a lot of it is we don't know why it does, what it does, little 10-degree changes, a little bit of air here, a little bit of this there. You know, there's just a lot of interconnected pieces as far as the physics go of how the plastic is formed that play in that, you know, I don't know. It leads us around like a leash. There's some weird dynamics with plastic. So the whole idea behind this swing arm here is when it's done heating up, it'll swing out and cool for a set amount of time based on the batch that we designed for this part. And then that way we have good thickness on our piece, because otherwise if we tried to pull this far up, basically we would pull really thin on the sides of the mold, and you know, no one wants that. It's just bad part quality. So this is our powered by Amazon and caffeine induced ideas little cooling unit here that honestly it's worked pretty good. I'm surprised. So I think I've only actually spent like real tangible money probably under $1,000 adding all these. It's largely pneumatics. You know, it's under a couple grand. Largely at this point, as it is now, all you do is you take a piece of stock plastic off of whatever loading thing we have, wherever it is. You just blow it off you want to get all the dirt off of it, you know, so you don't get impressions in your plastic. And basically you just set that piece of plastic on the former, close the clamp door down on it, and then hit go. And then you have your part number selected, which populates all of the settings. And then it just makes a part, and then once it's made, you unload it. Nothing more to it than that. the whole machines, that one was very manual and part quality would often fluctuate. With this one, everything pretty much comes out the same every time. Aside from automating the pre-existing processes that were otherwise manual, the biggest addition that we made was something that I guess we later found out that other people do this. Now this is very ghetto, but it basically is a vacuum hood that pre-stretches the plastic before the mold goes up into it. We thought we had a revolutionary idea, right? Turns out we found that some people in China also do it, but it's called a snapback hood. You know, we thought, well, if we can vacuum the plastic down, by golly gee dang it, why don't we just vacuum it up? And cool and form, and then our fans kick on, and then we have a finished part. But once the mold is good and warm, oh shoot, this is a dropper. And I would say that's the most aggressive improvement that we've made. Tommy, run my mouth.
So we've got a part was good, part was bad. This part was our first part. It was bad.
Basically, the idea is for this CSV file, which is a glorified Excel spreadsheet. And so just to capture if we're making good parts or bad parts and to capture our scrap on the thermoformer, I was putting in a good part, bad part functionality. Like I said, everything's continuously changing, and I'm actively altering the automation on this machine like every other day. Yeah. So a lot of times you don't get it right the first time. Just hit part was good. Hey.
Part was good is not working either.
Hey. And this is where Luke has to go change the automation. No. If you're not cussing, you're not trying sometimes with that stuff. But yeah, I mean, we just got all ironed out where it pops up at the right time, and then, you know, it just does its thing. All right, so, wait, what did I want to say? Okay, get your YouTube brain on so you can talk. All right, so we're making a few changes, I guess, to this machine. It's the ever-changing rig here, and basically we installed this vacuum hood a little while ago, and the whole purpose of it is to pre-stretch the plastic up. Basically, we've had a difficult time controlling our vacuum force on this hood. At the moment, it's timer-based, and you know, you just have some variability in that. Sometimes there's residual vacuum, and so it's pretty picky, and the operator has to do a lot to dial that in, and so I'm trying to mitigate that. And of course, you know, we're going to do it in the most Janko way possible. But if we go in here, I did some of the programming for it when I set up this vacuum hood. I'll see what I got in here. And so I have a time-based setup here, and then I have inches of mercury threshold based, where basically what I'm going to do is add a little controller that I designed up. It was for something else, but it'll work for this. And we can basically track the vacuum on our charge tanks and then cut the pump off when we've reached our correct vacuum setting. So we're going to use a map sensor from like a 2004 Chevy Impala or something like that and get it all calibrated in. Yep, safety first. Got the dullest drill bit. All right. And the absolutely do not ever do moment here. I'm gonna tap it with a drill. This is the gross part. My old buddy Ethan from my previous job taught me that trick. Probably makes more sense to have this down, maybe. Okay. So I got some plumbing to do and then some electrical. Basically the way it works is it's got a little Darlington transistor, and the way I programmed it is it's just going to send a negative signal back to our PLC. It's getting kind of tight in here. I think I got one relay I haven't used yet, so I think I can change that. It's an output at the moment, but I can rewire it as an input to our little smart stick expandable I/O block. We should be good to go. Luke's up there putting parts away. Just got back from lunch, so he's gonna run this thing right quick. Most of my electrical work I can disconnect it from the panel so I don't get electrocuted, with the plumbing here I do it real quick and get it before he's running the machine again. Obviously with thread tape you always want to turn it in so your tail ends at the end, so when you turn the part in you don't unravel your thread tape. Makes good sense, right? Okay. In theory, that end in there, about yay area there. So definitely not for cutting. Pneumatic tube works. Alright, might cut it a skosh shorter. I'm going to drop that in our heater bed. Alright, that ought to do the job. Mint. Is there anything left on that machine to possibly automate? You know, on that particular machine, I think we have it pretty much down. I could go through all the narrative things of what we did, but there's really nothing left that I could think to add to the machine. Now, if we do improve the way that we do make our molds, so it's not like Caveman 1.0 style at a later date, the only addition I could see to that is where we would thermal regulate our molds so we don't have heat transfer from our plastic into our mold. Once the molds get heated up, they're fine, but the way we make them right now, we can't do that. So, you know, in the future, if we ever improve, which we're working on right now, but depending on the way we go with that, then we could possibly thermal regulate our molds. But other than that, I mean, the thing is, it's done, I would say. Our cycle times are just dang fast at this point, faster than we can handle any part of the other part of the production process. So right now, you know, everything else is a limiting factor. The thermoformer is setting the pace